Hello, fellow Mythrunians! Welcome to another weekly live stream. Tonight we're going to be continuing where we left off last time with pathfinding. I've done some background work in the meantime to kind of make that go a little smoother, but not much else to cover, so we can jump right in. Up in the upper left, you can see where you can download the most recent version of the game. And that's also where you get a link to join the Discord, and we have some interesting conversations there sometimes. Those are the patrons. They help keep the lights on. I don't know if I'll break even this year because the domains and things are on a 2-year cycle, so this year's the expensive year. But we'll see. Maybe things will pick up before the end of the year. But thanks to everyone who continues to contribute. It really does make a big difference. So let's get started. Hope you all had a good week. I had a pretty good week. Productive. Okay, didn't do anything with Mythruna except for confirm some things related to how big of a space a character can fit through. I've been messing around with, sort of cleaning up the physics playground so that we can jump right into pathfinding. To remind everyone where we were last time, we can start the simulation with the playground. Now look, there's a door there. I added object support. So we can drop a thing in where we left off last time. We can say, I want you to go to here. Uh-oh. And now that's not working. Oh, no, it is. Yeah. That's a warning. And then you can say step, 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 and she'll do the pathfinding step till she finds the thing. And I tweaked it so that these are on the right grid and it always finds the right thing and so on and so forth. It's ignoring the world at the moment. That's what we're going to work on today, where the pathfinding will actually pay attention to that. In light of that, I've started prototyping how the physics queries will work, and so I did this little test which basically projects out a bunch of little physics queries. So I talked about hitting the world directly, because we've got all this cellular block data where, I know this block is filled, this is not. And then going back and doing the object intersection, but it occurred to me that the physics engine is already doing that. So if I just ask the physics engine, give it a simple body and say, does anything intersect here? It will tell me. And that's what this arrow is basically saying, that we hit that and there was an intersection. I'll show you what the... I have the ability to turn on what we're querying. And so if I hit this again, it'll show this is the path it's querying, right? And so where it hits these will get... I think we just hit that one, and so we got an intersection that had that red arrow. I don't know if you guys could see it before. See, we're underneath the ground, so there's a red arrow. Let me get rid of these again and you'll see it. Son of a... Did ops really disconnect? It says no, it reconnected. If anybody's on the chat, can you tell me if I'm still broadcasting? Ops is getting really annoying lately. Yeah, it looks like it is. Okay, so I'm not going to worry about that. I really should bring it up on the separate screen so that I can see. Anyway, so yeah, we have the ability to do that. If I put the debug stuff back, you can tell that I'm actually querying at a much higher granularity than... connection was a bit spotty, but it seems working. Okay, cool. So you can see I'm actually querying quite a bit more often than the block spacing of the world. And that it occurred to me that we're going to have to do that in order to deal with, the partial blocks and things. Like, if we're just querying on world block centers, we would never be able to navigate through these types of spaces. definitely not through these types of spaces. And I confirmed in Mythruna you can actually walk through these. And so I think we're going to have to step at a smaller size based on, and actually this is even too far apart because you can see she could technically walk through walls if they happen to fall right between where she's querying. But it's working pretty good. If I make another one up here on the up on top of this ledge and we do the test again, you can see that it found the pillar, and not only does it find the pillar, it finds the let me take the shapes out again. Finds the pillar. It also finds the top, so you'll get some of these let's see, can we see like down arrows, so it, you know, her head would have intersected. So what I've done is, let me stop the simulation, and I've made a different playground. So we can start the simulation with that playground. And this one, you know, is like more like a maze. And so what we're going to focus on, the 3D aspect is important, but it gets very complicated very fast. And I think from an explanation and algorithm perspective, we can stick to 2D, and then we'll be able to really see, you know, how the algorithm is working, what the heuristic is doing for us, and so on. And so I've included more things like these narrow angled passages, narrow straight passages like this. We can put some more doors and things in if we just decide to. The it's interesting that it kept these. It added one, and yeah, so there's a problem there. The one thing is, I've noticed that even though you can put her in here and we can normally walk through, she does. Oh boy. Maybe, oh, this is the old one, so we got to use the new one. Okay, so she does this rattling bit because really the character only barely fits in that space. I checked in Mythruna, and we can actually walk through that, and it is a little jittery, and the physics doesn't like it, but we can actually walk through that. You'll see she totally slowly turns sideways. So I think what we're going to have to do is, you know, pick a shape for her that we like, and then step that evenly, make a grid out of that, and step that evenly. So it'll be a much smaller grid. The algorithm is exactly the same though, and if we use an actual SimSilka math library grid, we can easily turn that into unique keys and things. Yeah, the other thing I was going to talk about is, you know, the other thing we're not dealing with yet, and we will have to deal with, is if she's walking up on top of walls and stuff, we need to deal with the fact that she probably doesn't want to fall off. You know, if she was walking from, you know, say this location to this location, she'd probably want to stay up on there. And so, in addition to just querying the things that are blocking us, she's eventually going to want to query, you know, the drop-offs, and only be willing to drop down certain drop-offs and things. So that whole idea that where's my thing? So that whole idea that, you know, a step has a certain cost is going to vary a lot by whether she's stepping up, stepping down, climbing up, climbing down, and these are all going to affect her pathfinding. And it's not always in a logical way. So I've been thinking about this a lot this week, and the basis for how much it costs to move from this spot to this spot has got to be based on sort of time, the time it takes her to do that. So if it takes her a little longer to go up a hill, it takes a little longer, and so on. But within that, we need to be able to add costs to things that are beyond time. So that's sort of the base time. But for example, if she was standing here and she could climb up this wall, and it only took her a few seconds to do that, then a straight time-based pathfinding is going to prefer that to maybe walking all the way around, which might also take 5 seconds. But a character is more likely to walk around than to climb over the wall. It would just look silly. So you really only want to have her climb over walls when it's like the last resort. So you've got to make some things that the physics says she can do it, but she's very unlikely to do it, and so the cost function becomes very complicated over time, because even beyond just what we've talked about now, if she was running away from a bear, she'd probably scale that wall rather than walk around it, that kind of thing. Or normally a NPC wouldn't walk through another NPC's house just to get to the street across the way, but again, if she was running from a bear, maybe she would. That kind of thing. So the cost function becomes very complicated and based on mood. But we're going to deal with just sort of the straight, can't go through walls. I just want to illustrate what's going on, and this will be the basis for everything else we do. So we'll make her cost function very straightforward. Like, walls become super expensive. She can't go through theirs, or infinite, basically. And then the paths are open, and we'll work on whether we can actually, see what she's doing. Anyway, I'm going to restart this to get rid of that garbage. And again, let me know if you guys have any questions, or if you guys thought of anything over the last week. But we should be well set up to play with this. The other thing is, it occurred to me that I can easily illustrate sort of what the heuristic is doing for us now. But I think it would be clearer once we have an actual maze. We talked about how the total cost of a path, she's figured out she needs to walk this far to here. The total cost of that path includes a heuristic, which sort of is the fitness for how close she is to the destination. And that fitness function is very important, because it will basically control. Let me talk about this a little bit, and then we'll readdress it when we get to actual pathfinding. We'll readdress it. But so let me find where we did that heuristic function. It's down here in the find path. Or no, where did we define the heuristic? I thought I made it pluggable. Yeah, heuristic right here. So right now we make it super penalizing to walk in the wrong direction. If you set the heuristic to 0 so that we never factor in the distance to the goal, she will wander all over them. She will try every path before she gets there. So we want her to go here. Note for those who are new, we haven't actually implemented intersecting the walls yet, so she's going to try to walk straight through the walls. But if we step, she's basically going to step out in every direction, up, down, sideways, because she's searching every path, right, regardless of how close they are to the end. And so if we begin to estimate, like if we change this back to regular distance, then she tries to estimate and head generally into that direction. And so if we step, she will try to sort of generally head in that direction. But again, like, going this way and this way is the same distance as going this way and this way as far as the heuristic goes. We're ignoring the walls for a second. And so she will search a whole lot of space around herself before she finally gets there. And so if we increase the heuristic so that it basically, like, if we go back to distance squared, that's basically making it more of a penalty to go in the wrong direction and less of a penalty to go in the direction. So she's going to prefer. Yeah, and I screwed up because I didn't clean the path before we did that. At any rate, you kind of get my point. I have to restart now. It'll maybe be clearer when we... The thing is, like, for a really complicated maze, it might actually end up being more efficient to have a really bad heuristic. Because... if there were a lot of dead ends here and we started her in the middle, to get to some corner of the maze, she might actually have to try all of the different ways, and having her focus on ways that only go in the direction, first, go in the direction of the end is going to have her waste a lot of time when she might have found the way better just by trying all the different paths. But in general, the heuristic is helpful because it eliminates a lot of work. So two things we got to do. One thing I realized we did wrong last time was I evaluate whether we finished. Oh, I fixed this. So I evaluated before, and I left it commented out to show. When we try a step, so we're heading over here, and we step. We branch out from her location in all directions. And last week we were checking when we branched, did she arrive at the goal? That's what this was, right? Did we arrive at the goal? And then we decided we were done. That's actually not correct, though, because in a given step, or this step may arrive at the goal, but there could already be a step that is going to be a lower cost that hasn't been evaluated yet. So, for example, if we had, if we were heading up here, she could try this step, and then she could try, this step. In one case, she could head straight here and try to climb the wall, and traversal-wise, climbing the wall in this direction might get her there in 3 steps of the graph, whereas there's a ladder here that gets her there in more steps of the graph, but in more steps of the graph, but is actually a lower cost. And it could be such that even though she takes this way and she gets here, the cost is still higher than all of the other things we have to evaluate, and there's actually a better path for her. So the bottom line is we can't evaluate in the point where we're choosing what the next step is. We have to evaluate where we're pulling one off the queue and deciding if we're there yet, because then we know that's the best path so far, because the queue is prioritizing based on the cost. I hope that makes sense. I can draw a diagram if it doesn't, but at any rate, excuse me, the Pepsis are catching up to me. So I think initially we're going to play with trying to go in here. And I have to pick a grid size. And the interesting thing is, for those of you watching, because whatever grid I pick is going to be imperfect, it will be possible to build things with objects that a player can traverse that the NPCs will not know that they can traverse. So that'll be interesting. Like, we'll set up the grid evenly on, quarter blocks or something, which means that an NPC could walk through this, even though it's only like half a block wide. But if you moved this over just slightly with an object, then a player could walk through and an NPC couldn't, because it would be trying to navigate on that grid. So just a little cheat for you if you want to have a place you can easily get in and out of that mobs cannot, unless they're smaller than, because eventually the query size will be based on the size of the mob. All right, so one thing is I had used here the directions that the block library defines. When the thing that renders these blocks, it needs to know for a given cell, things that are up, down, left, right, north, south, east, west, up, down. And so it has a direction idea built in. But we're going to make something different, because not only do we want to know diagonal directions for one, but we need to know relative costs between, moving from one place to another. Also, for this initial pass, we're going to limit our directions to only, the 2D space. We're going to ignore up and down for the moment. So instead of using the built-in direction class, we're going to make our own little dir info, and it's going to have we probably want a name, just so we can print something useful. just to get, in case we need to debug something, we can print it out and we'll know. We will want a vec3d direction. Yeah, that's fine. And we will want a base cost. So that'll be, you know, despite anything else, that'll be the cost for moving in that direction. Because to move in the direct axis aligned directions is going to cost 1 of whatever unit we're doing, and then moving diagonal will be, you know, square root of 2, because, you know, Pythagorean theorem, 1 squared plus 1 squared square root. Let me know if I need to draw a picture for that. String name vec3d dir, and we'll calculate the base costs. This dot name equals name, this dot dir equals dir, this dot base cost equals dir dot length. All right, and that should get us what we need, and then we will want to make an array of those. Directions equals new dir info north. I'll just call it n. Yeah, lowercase n, that's fine. N, and then in this world, it's in xz, and -1 is north. So north, south, east, west. And so south would be 1. East would be 1, west would be -1 in the x-axis. So those are 4 cardinal directions. And I'm going to do north, east, south, west, so it's like clockwise from north, which means we can squeeze in northeast here. And what we'll do is we will, northeast will be this, and then we'll say normalize. So basically that'll make that direction a normal vector, normalized vector, length 1. So the east, southeast, and and then west, southwest, and finally northwest. Just -1. Okay, so we've got our 8 cardinal directions. Should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Yep. And so now we can calculate in all directions. And we're going to set up a grid, I think. Path grid equals new grid. What does the constructor for grid look like? So did anybody do anything interesting this week? I played too much. Well, last Saturday was my wife's birthday, so we spent the day doing birthday-related things. The kids and I went out and got her something. But then, and we had dinner at Cheesecake Factory, and then I felt sick and played Astronauts until I felt better. Yeah, spacing. This is the problem with the grid class, is it's based on integer divisions. So we cannot use that. For what I wanted to. We'll have to rescale it. Anyway, I flipped another ship and got like I exceeded $2 million in that game. That just means that some of the challenge is over. Let's see, does grid default to 1 cell? No, as so we could just, I don't know if it doesn't even make sense to have a grid if we're not going to have, so let's just say path scale equals 0.25. So we'll make the grid operate on 0.25 boundaries, and so then we will want a couple functions. World to path. Okay, so this is going to take a world and turn it into a path cell. And I think let's just say world to path grid. And we will world to path cell, and so we will take the world, essentially divide it by 4, and so there'll be for each cell there'll be 4 by 4 cells inside of it, if you want to think of it that way. That may be actually too granular. Let's just try 0.5 for now. Okay, so what do I want to do here? I want to multiply. Alright, so let's say world to path scale. World to path scale is that path to world scale is 1 over world to path scale. Actually, let's do it the other way. Path scale is 4 or 2. Path to world is 1 over path to world scale. Alright, and so when we have a world coordinate, we want to multiply that by world to path. And then we want to actually want to just take the floor of that. So that'll quantize us to an even cell. And then we say path cell to world is pos dot no, I've done something wrong. Wait, so this world scale says, yeah, no, this is path to world. I've got these backwards. It made sense when I wrote it, but this is actually world to path. So, and this is I cut and paste something weird. A path to world scale equals this. So to go from world to our grid space, we have to multiply by 2, and to go from path space to world space, we have to divide by 2. So world to path cell means that we take the world position, we multiply it by 2, and we take the floor of that. So, you know, this, if this was 0, this 0.25, so we'll basically multiply that by 2, we get 0.5, and anyway, we divide this into little 2 by 2 squares, basically. And we just need to return that. We don't need to do anything special. So then return pos mult path to world scale. And so that'll, if you ran a position through this one and this one, then you'd get like a quantized corner. And then we could add to that. So let's rejigger our loop to use these directions and these functions to convert to and from stuff. Yeah, and so then basically each of these will multiply by path to world scale. Yeah. You'll see. Alright, so this no longer works for finding our cell. Our cell will be based on world to path of the goal. Right? World to path cell. Yeah, okay. So world to path cell, blah, blah, blah. Goal cell, that's fine. And then when we want to create a cell position, we'll say cell position equals path to world. Or is it path cell to world? Path cell to world, yep. I was smart. Path cell to world. Cell, and we will add. We want it to center in the cell, so we'll add. Oh, it has this capital C. That was gonna mess me up. Yeah. Let's do center. We're gonna pack it all up. So we'll add like half a cell back again. So that we get just do add local for this. So that we get like in the center if we do this path to, we're going to do this a lot to do debugging. So there we go. So that should make our center. We added this because our sphere is, no, we added this for bad reasons. I created a debug shape and the, oh yeah, I added text, by the way. I don't know if you guys noticed that when we were doing the thing. I forgot to mention I added the ability to have debug text. So yes, we don't need this anymore. We can just do cell pos, and it'll put us in the center of the cell. And we should probably make this a function of the path spacing, but it's okay for now. And then for this, we want to do cell pos dot add and 0. We want to just be big enough to go over the cell size plus the height of the text. So the sphere is 0.25 radius, and so 0.45 will take us, should take us over the thing with the thing and the stuff. And so the start is, we're going to need to do similar. I'm going to comment this out. The start is going to be world to path cell, just a little bit above the where it's standing. Yep. And I think path cell is a vec3i. Yeah. And so then we start there. And that's all fine. I hope you guys understand what I'm doing here. Basically putting these on a smaller grid that we can control. Okay, so when we get the goal, the goal distance is okay. It's okay if we still do this on the grid, because we're just curious if we've made it yet. However, candidate location is going to be a vec3i now because it's on the grid. We're going to do everything on the grid until it comes time to display it. So yeah, candidate start, so that's already, path cell is a vec3i, so we're good there. And so we don't have to do this anymore, but we do have to have equals, let's do, what did I call it? Path cell to world center. Anytime we turn these back in, these grid positions back into the world, we have to pass it through that function. And so key pass, you know, there's actually a bug in here. Pass has to be to vec3d first, as does this. I think so. It's possible that vec3i has a mult method that takes a vec3d, but or that takes a double, but I don't know for sure. Anyway, so we got a key pass add. We just want to add 0.1 now, because I don't know. Remember why? Oh, we're making a little box. I don't know why we put, oh, because it's a little taller. Yeah, so that way it sits on the floor. And then key pass dot add. So this would be 0.9, and that's all good. And so all of this currently works okay because we're not actually querying the world yet, but we want here, we want that key pass again. And so then check the key pass. This is just, we don't have to add anything, it's already where we want it to be. That's good. And this would be key pass. We're just going to add that 0.3 so that the text appears above it. Okay, so that should do what I want. Let us see. We want to say go to here. Oh boy. Hurrah. Vec3i, okay, so vec3i floor, I've done something wrong. G410. Oh yeah, don't have to do this anymore. That's the other thing, I put in stuff so that these shouldn't kill the application like that. It's not working. Who called it? Oh, it's because it's in that, yeah. It's because this was actually a callback from something I can't control. And because it was a compiler error, I can't even protect from it in the script. So we shall try again. How did it get to be 9:40 already and I'm still messing with this? So let's do this. Create the mob in the middle. We want to go to here because that'll be a nice path to follow when we get there. Okay, so that's all good, and it put it in the right place. Yeah, see, it's got little text above it. Now we can step. Okay. What is it not like? Distance squared is applicable for vec3. Yeah, okay. That's unfortunate. That was that optimization somebody mentioned last time. So I switched it to distance squared. But vec3i doesn't have a distance squared. It does have a distance. And it does return a double, but... Alright. Yep, so I can't clean the path, but I have to do a different one. Go to here. Okay, so then we say step up. Okay, clean path this time. See what we're messing up this time. No, vec3i doesn't have a distance either. Oh. Well, that sucks. I don't really want to fix that. So I'm going to do just all kinds of stuff that'll be performance improvements later. Did I clean the path? I did. Okay, so go to here. Alright. We say we should have little bitty steps this time. Step up. Once we get rid of all the bugs. Cannot cast object vec3i with class to vec3d. Where are we trying to do that? 443. Current.add. Current is the candidate location, so that's a vec3i. Oh, this is what it is. We're all on a grid now, so we're in integer land. And I didn't clear it again. I need to fix that. Okay, so we've got... Whoa. Oh, we somehow ended up under the ground. So clean the path. Try again. There we go. My point 1 must not be doing enough work there. Okay, so we're trying to head here. Step. Nope. Once I get this work, I'm going to restart to clean up all that crap. No signature of method floor is applicable. Well, somebody's still doing a floor that doesn't need to. 445. I probably could look for, yeah, I probably could look for all of the floors. Yep, need it there, don't need it there, don't need it there. Okay, finally got rid of all those. Okay, let's try again. Please try again. Twink. Okay, step. Nope. Something's still wrong. At least we don't have to compile and run every time, right? Distance squares up. Oh, that's right, the heuristic. So I am going to fix, in fact, vec3i to do the... I hate this. I captured the wrong thing. There we go. Alright, let's try this again. Oh, I didn't clean the path, did I? Nope. Alright. Go to here. Yay! We failed outright this time. Okay, no signature of... Line 385. Yeah, but where were we calling it from? Somebody's mixing types. 406. Heuristic goal start. Goal. Oh, yeah. We want cell here. That's been a problem, long-standing problem. Looks like fun is being had. Well, fun from a certain perspective, yes, sure. And while we're here, I'm going to go fix my open source project to have sensible methods over here. I think I do have, yes, we have get distance squared. Yeah, I deprecated them over these. I have these. Yeah. Oh, why is it returning int? That's not good. Oh yeah, distance squared. Sure, it would be an int. So why wasn't it letting me do these? Alright, problem for another time. Good times. Alright. At least this will clear out the paths. Alright, so let's load playground 2. Start simulation. Gentlemen, start your simulations. Alright. And so we want to go to here and step. Yay! Okay, so we got little bitty step sizes. It should make little bitty step sizes. Oh yeah, I've still got the... Oh no, that's doing the right thing. Okay, so it's not, again, right, we're not querying the environment yet, but it should make it. Yep, okay, so it went right through the walls to make it there, but now we're on the right track, and we can see that we have the granularity necessary to pass through these thin passages, right? So we're getting there. Now, what I want to do is not search in 3D, and I want to search diagonals. So we've got to change out this right here for, let's do, where's my directions each? Dir info. Actually, let's type it. Dir info. It is a dir info. Just to make sure I don't screw something up later. Okay. Hold on. Oh, this is interesting. Yes, so when I did this normalize, I don't want to do that because we want this to operate on the grid. In fact, I want to say that all of these, just to force myself to think this way, should be integers, integer-based directions. Because we want even steps on the grid. So when we go diagonally, we want to go all the way to the diagonal cell. And we want to know that that was, 1.44, whatever, square root of 2. And so that's good. So dir info, so we can add just dir info dot dir. And that should do it. Right, we don't use dir any other place. Alright. Oh, and I didn't clear the continue statement will only allow, oh yeah. Can't do continue. And I can't clean the path anymore either. Oh, I can, because it didn't actually recompile the script. I need to fix that so that, could not find matching constructor info string vec3i. Oh, I didn't change it. Like I have this for the other thing. I created a this. So if not binding, not binging, has variable path entities. So we'll have something to add these to, and then when we clean the path, we can just clean all of the path entities rather than trying to remember which ones we created before. And so whenever we create one of these guys, the delete me stuff, because the delete me's won't survive a restart of this script. And so we will add them to, what do I call it? Path entities. So let's change delete me to path entities. Skip that, skip that, skip that, replace, replace. Skip that, replace, 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 replace. Skip that. And instead, we want to say path entities each, ed remove entity it. And so now even if I screw up and forget, like if I set this and I do a couple steps, yeah, see now it's only working in 2D, and I forget to do it and I change something about the script and I redo it, clean path should still work to clean the path. Yep, yay. Alright, so we've got everything set up, and now we need to do actual queries so that we actually do pathfinding. So I'm going to clean this up a little. And in our loop here, if we haven't already been there, we want to see, is this going to hit something? Right? So we want to do, I wonder if the, I'm hoping that the collision objects, even if they're fully contained, will still come up as a contact. That could be a problem. Like if we ask right in the center of a block, what I'm worried about is that we'll ask right next to a block and not get a contact, and we'll ask fully inside the block and not get a contact. And so that we'll pass right through walls. Because I think in Mythruna, once you're inside of a wall, you just fall, right? It doesn't know you're hitting anything. Alright, so is this going to hit something? We need, where's my debug code that I added before? Up here. So this, we want to get the physics space. We'll get it up here so that we don't have to do it every loop. Alright, and we need to have a shape also. Def shape. What did I call up here? I'm going to use the same. Oh, it's already set up. Character shape. Character shape. Set up to be 0.3. So block is 0.15 wide. We actually want, let's make a path probe that will be good for our current grid size. So I think we'll want it 0.5. And then we'll, of course, want to change, if it's 0.5, then we only want to be 3 blocks tall, I think. And let's just see what that looks like. Oops, bad things. 448. I've done something. Oh, I've left this. Yeah, okay. So let's hit the test button and see. No, I want to see the things. So let's turn debug path back on. Let's do it again. Test. Okay. Is that really 0.5? No, that can't be 0.5. Oh, yeah. No. That's not what's wrong. Yes, it is. So where I created down here, I wasn't using the right size. And then these need to be character scale times half a block. Let's call it offset. And we can just plus offset minus offset. Happy Friday, Lando. How's it going? Lose any Millennium Falcons in a card game lately? Okay, so let's test again. Whee. Okay, so that's the right size for now. Too many to count. Why isn't it moving though? It was before I messed with things. Step size 0.5, that's right. Maybe it crashed. Yeah, okay, that's what no such property offset. Oh yeah. Okay, let's try again. We just got to keep trying until we get it. Okay, so something's still wrong. Something's not using this, and that's this down here. Where we create the debug shape there. Okay. So this is what our queries will kind of look like, right? We're a solid block of stuff. Now if I turn off the debug, I'll be able to see if we actually still intersect that wall. We do. I am actually going to put these back. I just want to create the shape slightly smaller so I can see what it, because we're not on the grid, so yeah, we're not really testing what I wanted to test. So let's go ahead and make start equals world to grid to path cell start, and then start equals path cell to worlds to world. Okay, so that should do that, and if I do this again, cannot cast vec3i with class. Who's trying? 226. Oh yeah, because yeah, okay. Yeah, I strongly typed it, that's why. Okay. So now we all line up with the half grid, and I can see, yeah, we got a bunch of collisions with ourselves. That's fine. But I can see if we intersected the world at all by turning off this. Trying again. Okay, we still intersect the world. That's good. And even we're smaller, so we're really not intersecting with the actual side at all. Okay, so that's good to know. Yep. If true return, I just want to be able to clean up those arrows. Test. Yeah, okay. So now we have the foundations of getting to do our queries. Oh, you know what? Actually, I want to see this one more time. I was curious. When I change the size, I want to make sure that the height is right. Oops. Okay, so that is incorrectly placed. Oh, because of the grid, right? Yeah. So once we do that, let me... Oh, you know what I can do? I can just turn on the body debug to see. Yeah, so that block is too tall, but it's also up too high. So we will figure out what offset we need for these blocks to query where we want to query in the cell. Hold on. Excuse me. Okay, so we don't want offset here. We want like 0, 1. Test. Uh-oh. That didn't work. Oh, durr. There we go. Okay, actually it's okay. It's just out of her head. We just need to come up just a little. Actually, I'd be happy if her head just... Yeah, so it is 0.125 like it was before. And go to... Oops, test. Oh, it's actually a little higher. Okay, that's good enough. And we'll get the point across. I just want to make sure she doesn't go through doorways she can't go through. Cancel. Ooh. Ah. That's good. Alright, well, we'll code a little bit more, and then we'll come back. Actually, no, because I was iteratively trying to find out where I need to query Lasai. It's because I had clicked the go-to button and I hadn't actually placed a go-to spot. And then when I canceled it, that code doesn't like that. Alright, so let's get our cooler looking playground. The maze. It's amazing. Alright, so let's do test. Okay, so we need to change... What are we doing? Somebody's setting... binding outside of BPOS. Oh, so somebody's setting BPOS without defining it first. Yeah, right here. Alright, so 0.125 is what we want to add. Okay. Actually, that's not... No. This is once we've already got the contact. It's where I'm doing the query. The shape POS. Yeah, we want to add our 0.125. Okay, Now when we test, something's still not right. Because we're still right on the ground. Oh, we query higher, but we didn't actually make it. So what we want to do is actually add this up here. Yeah. Okay. Whoops. No, we don't want to add that there. We want to add it everywhere we use it. Okay, so that we add that shape there. And shape pos needs to also add it. Okay. Test. Yeah, okay, there we go. Still, it's not in the right place. It is a little higher. Why is this one? Okay, I've done something wrong. So where is the... It could be that initial one... Okay, so already our... Okay, I see what's happening. This is being placed centered over her center of gravity, it looks like. So when we're adding 0.125, we actually need to add more. Yeah, so actually these are better. Alright, it's good enough. This will get us what we need for today. I'm not gonna sweat over the height because we're not dealing with the 3D aspect yet. So get rid of that. And we will mess with moving these queries. Okay, so shape pass, blah, 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 blah. Okay. Down here, we want to define, excuse me, neighbor dot add to vec3d. Actually, we want path cell to world neighbor. Then we're going to add the bound center to world center. That's what it was, right? Path cell to world center. Yep. Key and neighbor are the same. Then we add our little spot. Then we see if it has any results. If not results is empty. So if we find any contacts, we'll skip it. I'm gonna add debugging in a second because I think we're gonna want to know why it's skipping it. Let's see if this finds paths. So we'll say we want to go there. Who's complaining about what? Setting binding outside of init cell. I just want to fix that while we're here. 406. Yep. clear the path, just in case. Alright, back to what we were doing before I had to fix a bug. Wasn't a critical bug, but something else is doing it too. It's basically warning me when I'm leaking state between frames. Data line 404, 404, line not found. Yeah, def, there we go. Just in case, even I fixed that. Alright, back to what we were doing. Alright, so let's see what's going on. Alright, so that is, oh, we collided with ourselves. That's fine. That's a problem. But so far, we're alright. We'll figure it out. So it's taking the path, right? Yep, it hit a dead end and came out this way. I'm not sure where it's searching anymore. Are we out of paths? We're finding... Yeah, we might have run out of options. Oh no, we're still going. I don't know what it's searching though. Oh, you know, it could be trying paths and then hitting walls. That's what it is. We should probably put debug stuff. Anyway, it's about to find its way. Yay! Look, it found the path. And what we should have it do is when it finds the goal, it should highlight the path it took to get there, right? Because that would be useful. But yeah, so I need to have it put red marker. First I need to have it ignore collisions with itself. So the mob is currently colliding with itself, so let's clean the path. So we'll skip a contact if it's us. Let's see what that looks like. So go to here, step. Okay, so we hit a bunch of them that are us. And I think we could just compare the body. It's always going to be body 1, B1. Yeah, so if B1 equals, let's take this out. If B1 equals, we know what the agent is, right? Yeah, driver, rigid, body, return. So this should fix us from this clean path. So if we go to here, now it should no longer hit us. Nope, it hit us. And we have a bug somewhere. No such property B1. Oh, yeah, okay. Contact. Alright, let's try again. Clean path. Go to here. Step. Nope, still hit us just because we've still got a bug. Contact. Body. Okay, so I said B1, but it's body 1. Apparently the to string method is lying to me. I hate it when past me did that. And so let's try again. Step. Oops. Hey, it failed a lot quicker. Oh, I didn't say where to go to. Step. Yay! Okay, so it no longer, we are here basically, and it no longer collides. So if we did a step again, it's gonna hit edges and things and find its way eventually. kept trying to go through the walls, right? And there we go. Okay, so now let's make it so when it finds its path, it draws it. So when we find a path, draw the path. And we'll draw a candidate. And just in case we need the driver, we'll draw the driver. We'll send the driver in and the state in, just in case. So just put this here now because it's right here and we can see it. So driver, state. I don't think we'll need any of that, but just in case. Okay. So did I have a debug shape for a line? Doesn't matter really, but I closed all the debug shapes. I have arrow, sphere, box. We'll just use little boxes. Alright, so, excuse me. Yeah, so if I could spend the next few minutes drawing better debug information, and then we could talk about, again, what that heuristic is doing for us. And how in a situation like this, it's actually not as helpful as it would be if there were no obstacles at all. All right, so what we want to say is we're just going to be recursive. We're going to draw this location. First, we need to know where the location is. Path cell to world center. Candidate location. Add 0, 1, 0. Okay. And then where we do this little debug thing, I'm going to do something similar here, whatever this is. We want to set it at pos, and we want to create a little box, and we're going to make it green. And lit, that's fine. And then path entities, add entity, and then if candidate dot parent is not equal to null, draw path driver state candidate dot parent. Okay, so if I did that right, we should get a nice path when we're done. So let's say we'll go to here. Of course, I could have done a shorter path, but so step. Let's bring it over here so we can all see. Step. Okay, it's going to trace all the the bad paths again. Uh-oh, there it goes. Uh-oh. Yeah, I should use a shorter path to test because we got bugs. No such property driver for class setup driver 9432. Oh, drive 8. What the hell? Oh, because candidate drive 8. I got it. My fingers. Okay, let's go to here. We'll go to a shorter one. Step. There we go, and it drew the path. Okay, so now if we do a more complicated one, we should say step. I actually don't know why it's not trying these. It's a little concerning, actually. Hey, look, it shows the path. Oh, yeah, see, this is wrong. So there's something wrong with the physics queries. And I should probably be showing the contacts that we found. Like, why didn't it go here instead of here? I mean, it did go there. Oh, I know what the issue is. You guys know in the old video games that were set on a grid, but they would let you move diagonally. If you move diagonally, you go faster. That's what we have happening here. This diagonal to here is actually faster than going this way. Or it's the same cost because we haven't factored in... yeah, the diagonal is a single step and it's not costing anymore. So where we have the path cost, when we create our neighbor, yeah, this one. This needs to be dir info dot base cost. Yeah, so now if we do this again, so clean path, go to here, step, 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 step. I need to really show the failures and log their contacts. Okay, so now it's trying to go through the walls. Now it's going around. We're trying to go through those walls. Now it's going again. It's going to make its way around. And boink. Yay. Yes, they are. I just hadn't factored that cost in. And actually, why isn't it going... So here's another issue with the heuristic, is that the heuristic says this path is better than this one because for a brief period of time, we were closer to the destination, right? So the heuristic ideally... So I don't know if you guys remember, right? So the heuristic says as we get closer to here, we get penalized basically for trying to go farther away. And you know, based on the distance to here, the distance squared was higher here than it was to take this path. And so because it was headed towards there and then it evenly slid sideways relative to there and then went up here and around and found a nice tight path to get there. The issue is, I think I'm going to lower these down to be closer to where they hit. The issue is it's not taking these, which makes me think that our physics shape is either querying in the wrong place or is slightly too big. I'm going to say it's probably querying in the wrong place. But first, let's put debug information in to show where we hit. And to do that, I'm going to basically make debug shapes for the contact. So, yeah, so this. So if results is not empty, we'll go through each one of them and we'll add it to path entities. And we actually don't need to do this. Okay, so let's make sure we go through contacts, contact point, okay, so that should show us every time we hit something. So clear the path. Let's do a shorter one to go around here. So let's say step, step, step. No such property. Oh yeah. I'm used to some of these things being in the global space that I don't have to pull them in all the time. Loci. Alright, go to here. Oh, we went under the ground again, didn't we? Clean path, go to here. There we go. Step, step, step. Okay, yeah, so see, we hit when we went right here, but we shouldn't have. So I actually think we are querying a little too far in one direction. And I can, so we're hitting all those sides before we go around. And we seem to be, oh, we don't keep track of where we visited. So we're re-hitting all of these. No, we potentially re-hit the same spot. Yeah, that's true. Okay, it found its way. And let me show you what would have been different if we had like no heuristic at all. All right, so let's take a screenshot of this. Right? Let's set our heuristic back to 0. And you'll see it'll actually create a better path in this case. It'll just take longer to do it. So if we clean the path and we go to the same place, now we say step, step, step. It's basically going to go out in all directions equally. But in the end, what we'll end up with is a better path. Right? Because it'll be purely based on distance and not biased by the heuristic. Right? So eventually we try all of the paths, and eventually one more way, I think. Oh, a couple more. We get it. Yeah, it went right there. It goes. So see how it went straight this way and around and straight there? It didn't have this little dip where it like hugged the wall first. It took it a lot longer to find it. A lot more steps to find it. But the path in the end was better. And so I kind of think that the heuristic should probably not be squared necessarily, but be biased in such a way that it is less effective. It is still an influence, but less effective when you're far away than when you're close. But anyway, that's tweaking the heuristic is a age-old problem. But I want to figure out why. So in theory, let's put the heuristic back. So if my theory is right that I'm just querying too far in this direction or too far in this direction, then I should be able to go the other way, and we should see it like go right up to the wall and hug it. Yeah, so see, this goes right up to the wall and hugs it, and finds that. But you see how it missed here? So I think if we went down, that's be interesting. I want to see if it can navigate the, let's see if it can navigate the angles. Yeah, so see, so I'm querying too far south and too far, basically too far in the positive z and too far in the positive x. So some offset is too much. So we're hitting the sides too soon. And I think that's going to prevent us from being able to go down these yeah, we're revisiting the same spots again and again, unfortunately. Like, you can see, like, we've revisited this spot and we're not supposed to. So something's happening in the thing that's looking for if we visited that spot or not. That it's not detecting it properly. Yeah, so see, I don't think these are going to make it down. Oh, it did. Check it out. See, it's offset. Yeah, there's an issue here with offsets, but check it out. It made it. It figured it out. It will not figure its way out over here. It is not going to take the short path, I bet you. going to have to go the long way around, because I don't think it can make it down that... yeah, we're definitely hitting same spots over and over again somehow. Something in that... yeah, see, it's never going to make it there. It can't fit down that hole because it's offset by like 0.125 or something that's... yeah. So it's never going to figure out how to get down there. And that's what I was talking about. If the... whatever grid I pick, if you as a player set your physical objects like the door, to be just off of the grid, you'll actually be able to walk through yourself but block the NPC. And this is kind of, we're seeing that in action because it's querying on the wrong grid. One thing I want to see, let's make another mob up here and make sure he can't go through the door, because he doesn't know how to open it yet. So let's, like this, he should go straight towards the, or she, I should go straight around there and should hit the door, which they did. And so, yes, it's re-querying the same spots over and over again. So I need to fix that. And eventually it makes its way around. Yeah, so it goes around to the back door. Cool. So physics objects do impede its path. And now I need to figure out why. I can tell it's revisiting the same paths because like if we do this, it's a simple path. And the way I could tell for sure is if you look at the debug text, you see how sometimes it's doubled up. Like there's two numbers here. That's the cost, the total cost, the heuristic plus the path cost, and I really should make them separate, but so for whatever reason it hit this twice, but it should not have. So the key should be unique. If existing is not equal to null. Oh, we might have a better cost. That could happen. So if existing is not equal to null and our cost is greater than or equal to the existing cost, then we return. So you actually can visit the same place twice if your cost is better. But then I kind of want to... let's make a label offset equals 0. And so else if existing is not equal to null, label offset plus equals 0.2 or something. And then plus label offset. That's the text, yeah. Okay, so if we clean the path again, I just want to see where we were going. Let's clean the path again, and we're going to go right back to the same place. Need to fix that. Oh, why does it keep putting me underground? Clean path. Go to. There we go. Okay. So step. Uh-oh. Oh, I'm hitting the wrong. Yeah, I've got two of these guys. Okay, so let's delete this one so it doesn't confuse me. Go to here. All right. Step, 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 step. Yeah, now it won't tell me when it revisits it multiple times. Just twice. But we can see Yeah, for whatever reason, when it was here, it visited again and it had a slightly better score. I need to have a reset so that I can keep the same goal, but just redo the path because I want to see. So we step, we do those. We step, we do those. Everything's good. We step again, we do those. Now we can't go straight there anymore, so we're going to have to try some other ways. Yeah, and why did you even continue? Anyway. So these couldn't go. Those couldn't go. Yeah, so here's the first one. Right. Is it a rounding problem? It's a cost versus total cost issue. So if we debugged, it's because I'm doing it based on total cost, which is incorrect. So when we're calculating the fitness of whether I can replace an existing path, it's complicated. So what it is because the total cost is based on the heuristic and the actual path cost, we have that sort of issue where even though it looks like this way should be the same as this way, right? This way actually turned out to be a little bit better cost for the second step because we moved closer to the end point, right? So from here to here, yeah, was a slightly long, anyway, it's weird. I kind of get it because you see it's such a small difference. And I bet if we put the costs and the, like if I separated out cost and total cost, or cost and path cost instead. Let's say instead of this, we want this, and then %02f, percent O2f. So we just want, what is the candidate? Cost and heuristic. So cost, comma next, dot heuristic. And let's make the text a little smaller. Okay. So let's clean the path. We're going to go to here. Can you imagine how long this would have taken to debug in the game? Just saying. Okay. Something's wrong. I still screwed it up, even though I 0.02f. Oh yeah, I do this all the time. So yeah, imagine if that had been a restart Mythruna just to test the thing. Alright, so we've got both the costs. So this is the actual path cost, square root of 2, and the heuristic. So if we step again a few times until we get a second value on one of these. Yeah, so see, we hit this one twice. And it's the same heuristic, but it says it was slightly better. I'm not sure that makes sense. Okay, so we were... she's in the way, so it's tough to say. So this was... 1, cost of 1, cost of 1.41. How did this get to be 2.83? Oh, because these are partial. No. This is not 1.83. Something's gotten screwed up. So see, I can hand wave it away, but something is messed up here. because these should all be even steps. This to here, here to here, should just be 1. So that should be a cost of 1, this should be a cost of 2. This should be a cost of 3. Somewhere we picked up that 0.83. Because this is all in integer space. And this is why we write an application like this, right? So this turns out to be very useful because the cost is incorrect. Let me make sure. Base cost is set to the dir length. It's going to be 1, 1.44, 1, 1.44, 1. So how quickly do we see the problem? So let's clean the path, go to here, and step. Okay, everybody makes sense here. I wonder if it's because we go sideways from this one. We can actually visualize that. Yeah, so what I think it happened is, yeah, so what we did was we went diagonally from her to here. So we got 1.41. And then we went diagonally from here to here because the heuristic says that is better than going this way. Right? This is a better path to go next than this one. And I don't know why then we don't replace it. Oh, because 57.83 is going to be, this is a total cost of 60, and this is a total cost of or 56.83. That's always going to be less than anything that comes from this path. Like, I mean, total cost, this is still less than this one, and so we're going to continue pathing this one. And eventually we'll eventually decide to go back to this one. And that's when we double up. Oh no, we double up over here, but it's the same problem. It's the heuristic messing us up. If I took the heuristic out, or I based whether we replace an existing one purely based on actual physical travel. So if I make this, based on the cost and not the total cost, it's going to mess up the algorithm a little bit because it'll only replace things when they're better from an actual physical cost. But it should make more sense as far as never doubling up. Step, step. So let's see. So we should... Right, because we still chose to go this way, and we're never going to cross that way again. Oh no, we will. We'll double up as soon as we... Yeah, okay, yeah. So eventually... We're still doing diagonals. I should visualize that so we can see... Yeah, I don't know why it never hits this. Alright, so let's clean the path again and let's visualize the directions it's taking to get to things. So if we take the path, we want to, from the initial current, def arrow pos equals path cell to blah 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 from current. Right, current is candidate location, yeah. Okay. And so we'll create another entity. Arrow pos, geoshape, create arrow. I think it's tip, and so we'll use dir info dot dir to vec3d. Let me see. Debug shape, create arrow, tip, color. Yeah, lit doesn't make any sense. Color, RGBA. Let's make it cyan, false. Yeah, and then, all right. So that should show us how we got to certain places. So let's put, okay, step. Yeah, there we go. We could probably divide that, but so that's how it got there. Step, yeah, so see, let's make those arrows a little shorter. Arrow dir. Okay. Clean path. Go to here. Step. Still too long. Oh no, they're going straight into the things. That's fine. Step. Yeah, so see, it's taking the long way around. Okay. We didn't put any there, but I would eventually like to see which path we took to get into the wall. Okay, you see how we got here by bypassing this direct path, and that's because the heuristic says we should go that way. If we step again, so now we repeated the path because we decided we couldn't go the best way this way, and this way was a little bit more expensive than going this way, and so we tried back here and then we stepped to here. Now it should start here next time it goes down in this direction. Yeah, so we ended up back here. How did we get back there though? We apparently retraced our steps. Yeah, we revisited this with a slightly better score because we're using cost now and not including the heuristic. So, in fact, we're gonna try a bunch of stuff. There we go. Yeah, we're hitting the backside. We're revisiting things with slightly better scores, and so eventually we'll hit our solution and we go straight there. If we clear this path, oops, yeah, I'm gonna have to clear it again. If we change the heuristic to be just the distance so that it's not as much of a penalty, I think we end up with a slightly less nonsensical, maybe. So clean path, go to here, step, okay, step, 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 step. We shouldn't revisit, okay, we did, with slightly better scores. Yeah, so it's going to try a little bit more because it's not heading as directly there. Again, it's always a balance with the heuristic. It'll end up with about the same solution. It just takes it longer to get there. Right? And so it's all about tweaking the heuristic. Now I need to figure out why we're off by enough that we... yeah. So let's, I don't have to close it. Let's add some more debugging to figure out why we're hitting things. Okay, so the contact point. This actually could have been body 2. So it's better to check both. So if we had contacts, I wish I had like a wireframe box. But let's say if we found the contact, I just want to see what they look like again. So let's go to here, step, step, step. Okay, we've got some contacts. And the contacts, body 1 is a rigid body. I think that they have to be, and so we create a fake rigid body to do the query. That's unfortunate. And then body 2 should always be null. Yeah, so body 2 is always null in this case. Okay, so clean the path. So let's visualize where that body physically is. And so we ought to be able to we've got everything in that contact body we need. We've got the shape. So the shape is going to be, there's a trick to do this. And it's an abstract shape. Wait, we've got shape to body. No, it's abstract shape, I'm sure it is. Get world shape origin. Return the shape's origin in world space relative to the specified body. Yes. So if we have the shape, we should be able to get. So the shape is the contact body 1 shape, get world shape origin, contact body 1. And let's just see where that is. I'm going to create a red box. Okay. Oops. Something's wrong. Oh, I already have one. Oops. Contact pass. Oh, and this is incorrect anyway, so that's good. Alright, so let's clear the path, go to here. Step, 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 step. Okay. So this is where we were. The center of where we were when we hit the wall. Or the base position of, yeah, the shape that we used was there when we hit this. We can actually render the shape as well. It could just be a slight precision problem. So let's render the full shape. How do I want to do that? The width of our box. See, the problem is I'm going to have to do some calculations. We've got where do I create the shape? Too many things in this file. Character shape scale. Okay, so character shape scale is going to set what a full block's size is. So we set that to 0.49. Our block is 0.49, almost 0.5 wide, right? And so when we want to make a box with extents, we want to set, so let's see, def extents double ext equals half of that again. And so then ext, 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 and this will show us except for our box is not actually there. If we did this calculation, it's telling us where the world shape origin is, which means if we want to render a centered box there, we actually have to add this back. And this will make more sense. Or show the problem a little better. Yeah. So we're querying in the wrong place. It's not tall enough, right? But we just keep going to continue seeing the wrongness. Yeah. Yeah, so it's too far south for what we want to do and too far east. Because something is forgetting to think about the fact that the shape will be centered when we do a query. I think the shape is centered. Let me just confirm this is doing what I think it's doing. And then every place we see, oh, we're never going to reach our goal. Yeah, so see, already we're too far south here. I don't know why it's trying to head in those other directions. Anyway. Oh, because the heuristic is set so low now. It can't actually reach where it's trying to reach. So it's going to search the whole maze. And I'm just confirming that, yeah. So basically those boxes are offset by their own center when we're doing queries. So I've got math wrong here somewhere where this is concerned. So we add the bound center from, I think that this just needs to be world. There we go. Yeah, look at that. Okay, so that's fine because we can't see it, but it's inside the wall, right? Yeah. That's where it should be. When it's blocked, it should be inside the wall. So that's working. And so we should be able to step. Whoops. Step. Yeah, it's failing to go through the walls. That's fine. And again, our heuristic is set lower now, so it's going to traverse a little more to get there, but it gets there. Check it out. Alright, so let's clean the path and delete her. Create a new one over here. And let's see her go inside the room. Step. So it's hitting the wall, hit the door. So it's going to go round the long way. And we should be able to go down these little side paths now too. Although it appears no. Yeah, we did. So we're starting to go down the halls now too. What I should do is recenter my view so we can see a little better down the... Yeah, look at that. That's much better. Alright, so she's trying to search down those... Ah, she found it. She squeezed in the crack of the door. So that could be problematic. I mean, partly it's a problem of the door position, right? There technically is a little gap there, which I can fix. Let's slide the door back just a little bit. Set up objects. Minus 6.125. Let's do that. So the door should, yeah. So that's a more realistic door, right? There's not a whole lot I can do about that. So she searches around. She hits the door twice, so then she's never going to take that path again. Yep, so eventually she should go all the way around the wall. Again, we're still using the worse heuristic. So she goes down and she eventually finds her way there. And she takes it around the wall. Yay! Look, it's 11 o'clock and we actually got everything done that I wanted to get done tonight. And so you see how long it took her to find that way. And so like if we, hold on, I'm trying to get, anyway, whatever. I'm going to print screen this. We're going to go back and change that heuristic back to the one that makes it more expensive to wander farther. Right, and so then I will try to click exactly in that spot again. I'm going to put my finger on the screen here. I go to here. Uh-oh. Go to here. Okay, so let's show it again, this time with the heuristic that penalizes going in the wrong direction. So she's going to more quickly try to go straight there, and then she'll slowly work her way around the walls, right? And she's trying to go in that direction before she goes the other way. And eventually she'll slip around here and she'll find that she can real quickly get there. Yeah, she's revisiting those spots. Bank, right? Shoo. But instead of going straight this way and around, so let's take a screenshot of this. And I'll show you what I mean. Here, let's go to here. Okay, so this is the path we just took, which kind of meanders around, right? Because it's trying to go straight through that wall. And this was the one with the worse heuristic function that took her a lot longer to find, but you see how she makes a more sensible path. There's other complications in that if she knows the place well, she should be able to navigate like this. Like, you know how to get everywhere in your house, right, without having to pathfind, you know. Well, anyway, you know everywhere in your house. But if this is an unknown location, she would not know what's on the other side of this door. And if she was standing over here, she wouldn't know what was around this corner. And so from an NPC's navigating places they are unfamiliar with, this becomes a more difficult problem because you have to worry about line of sight. Like if she can't see over there, at best she could walk over here and then start trying to find her way around. She would basically manually be walking the A-star algorithm because she can't know that she can't pre-know that she can walk this way. She'd have to walk over here and kind of like hunt around until she figured out that she could go around that way. Same as you or I, right? We go, oh, this can't get this way, so I'm gonna have to try going the other way, and then maybe this is a dead end too, and you just can't get there. Anyway, so it's working, and I'm kind of happy with where we got. Let me know if you have any questions. I'm gonna like give you like 30 seconds plus the delay to ask any questions today. Otherwise, you can leave them in a comment on the video or join the Discord. In the upper left screen is a link where you can find the link to the Discord. It's a super secret link. It's that Mythruna.com/test engine build with the super secret password of dragon. Why dragon? Because the Mythruna logo is a dragon. And that's where there's a link to download the latest version of the game, which we didn't get to run today because there was nothing to show new, although it's still pretty. Very secret, yes, super secret. It just takes one extra step to do, which prevents like some of the randos from coming in, right? Eventually I'll get to the point where I really want to embrace those randos, but today I kind of prefer that the people who join are ready to have a conversation about the game. So that's cool. Alright, so if there are no questions, I'm going to go ahead and call the stream here. It's been a very productive stream. Thank you for joining me. Oh, hello. Things got dragged around. Let's go ahead and put up the thank you page. So thanks for watching. Like, comment, subscribe. Yeah, just click the little thumbs up on that video. It helps YouTube know that somebody liked it. And if you add comments, that makes it even more engaging. Otherwise, I'm not sure what we'll do next time. The Music Weekly's theme this week is Dungeon, and I'm really tempted to participate. So I may do an impromptu live stream sometime this week if I start working on that music. But otherwise, I will see you guys next week, and I'm not sure exactly what we'll work on. Probably pathfinding, but hopefully we'll get to the 3D aspect next week. And thanks for joining. Hope you guys have a productive week. See you next time.